Most of the relational database management system standards are defined by American National Standards Institute. So the transaction database transactions are also standardized by ANSI. Uh, in the transaction support, we have two important statements. The first one is commit, and the second one is rollback. These two keywords are used in the database transactions, and these are standardized or given by the ANSI. ANSI standards require that when a transaction sequence is initiated by a user or an application program, it must continue through all succeeding SQL statements until one of four events occur. According to ANSI standard, if a transaction got execution, so we will have four conditions, and these transactions and their statements will be executed until we have these four conditions. The first one is a commit statement is reached. All changes are permanently recorded within the database. Actually, in transactions, we use commit at the bottom. So if all the statements are executed and the commit statement is reached, so after that all these statements will be executed, and these will change the database permanently. Simply we can say that the transaction will be committed. The second case is a rollback is reached, all changes are aborted, and the database is restored to previous consistent state. We also use rollback in the transaction. So if we get an error during the execution of these statements, after that the rollback will be reached automatically, and all the changes due to some successful statements will be rolled back or reverted. Then the third scenario, a third case is the end of program is successfully reached, equivalent to a commit. If the program is successfully executed, then it is equivalent to commit. It is just like commit. The program abnormally terminates and a rollback occurs. If we got an error, after that rollback will be reached automatically and all the changes will be rolled back. Then we have transaction log. Actually, the database management systems keep a log for transactions to keep the track of all the transactions that update the database. In transaction log, we have few important things. The first one is a record of the beginning of transaction. Then for each transaction component SQL statements, and these statements type of operation beginning, the type of operation being performed, whether it is update, delete or insert. Name of object affected by the transaction, it can be name of the table, and even the columns are also used. Then before and after values for updated field. So before the transaction, if we have a value that is stored, and after the transaction the value which is changed is also stored in the transaction log. Then pointers to previous and next transaction log entries for the same transaction. So with the help of pointer we can access the next and previous transactions inside this transaction log. The ending commit of the transaction, and also we will have this commit statement inside the transaction log. This transaction log increases the processing overhead, but the ability to restore a corrupted database is worth the price. Actually, when the database maintain transaction logs, these logs are used for efficiency of data or for keeping the data in a consistent form, even though these transaction logs are heavy and they put some additional load on the databases. The transaction logs increases the processing overhead, but still these are better for keeping the database in a consistent form and restore any corrupted database. Then, if a system failure is occurred, the database management system will examine the log for all uncommitted and incomplete transactions, and it will restore the database to a previous state. If there is a problem during the execution of a transaction, then the DBMS look into the transaction log for reverting or rolling back to the original values of the database. The log is itself a database, and to maintain its integrity, many DBMSs will implement it on several different disks to reduce the risk of system failure. Actually, the transaction logs are used to avoid any sort of system failure. So these logs are itself in the form of databases, and these are maintained by the DBMS on different disks. This is the form of a transaction log. In transaction log, we will have the transaction log ID, then transaction number, previous transaction, it is the pointer to previous transaction, then pointer to next transaction, what is the operation in the transaction, and then we have the table on which the operation is used, what is the row on which the operation is used, and on which attribute the operation is used, before value and after value. For example, we have a transaction 101. It will first start, then it has update query, then again update query, and after that it committed. So with update query, the product table is used, this row is used, and this one column is used. The value before this update statement was 25, and after this update statement it became 23. The next topic is concurrency control. By concurrency control, we mean that if there are multiple concurrent transactions executing at the same time, then the coordination among such type of transaction is controlled, and this scenario is called concurrency control. The coordination of simultaneous execution of transaction in a multiprocessing database is known as concurrency control. Controlling concurrent transactions. By concurrent transactions, we mean that we have multiple transactions and all those transactions are executing at the same time. So controlling such type of transaction is called concurrency control. The objective of concurrency control is to ensure the serializability of transactions in a multi-user database environment. In case of multi-user database environment, we may have multiple transactions executing at the same time, or simply say that we may have concurrent transactions. So the main objective is to ensure that there is no conflict among these transactions, or due to the concurrent transaction no consistent data is coming, or there is no form of inconsistency in the database. In concurrency control, we have one important thing, that is simultaneous execution of transaction over a shared database can create several data integrity and consistency problems. If there are concurrent transactions, then it is obvious that some transactions may access a field at the same time, and such type of act may cause the issues with data integrity, or may make the data into inconsistent form. There are three main problems. The first one is lost update, the second one is uncommitted data, and the third one is inconsistent retrievals. Are these three problems are due to the concurrent execution of transactions. We will look into these three types one by one. So the first one is normal execution of transactions. Here we have transaction 1 and transaction 2. Two transactions are executing, and if we look into these two transactions, these are in serial form. The first one is executed and then the second one got executed. So there is no sort of conflict among these two transactions. The time slots are given to these two transactions and both performed successfully. Now, in case of lost updates, here the transactions are in a parallel fashion. Both are executing at the same time. In previous case, T1 got executed and then T2, and here we have these transactions in parallel mode. T1, then T2, T1, T2, T1, and T2. Now here we may get the issue of lost updates. Now look into this table. T1 read the quantity on hand, that is 35. So 35 is stored. Then T2 read the same thing and got 35. After that, T1 changed the value of quantity on hand. It added 100 with 35, and T2 changed the value of quantity on hand. It abstracted 30 from 35. Now if you look into this 35, it got changed due to T1 in the previous step, but T2 read it before this statement. Here at the time 2, T2 got it and it was 35, but before changing it, T1 changed it and made it to 135. So according to T1, the quantity on hand is 135, while T2 made it to 5. Now both updated the value and it's not clear that what would be the exact value. If we make it in a serial fashion, then T1 read it here and made it to 135. After that, T2 got it as 135 and made it to 105. So these are in sequence, and both the transactions are giving us the correct value, and here both transactions are in parallel fashion and they have conflict, and both the transactions are giving us some ambiguous values. Then we have uncommitted data problem. Uncommitted data occurs when two transactions execute concurrently and the first is rollback after the second has already accessed the uncommitted data. Both transactions are executing at the same time. One made some changes, but after that rollback. But before rollback, second transaction got something and made some changes on that uncommitted data. This violates the isolation property of transaction. We have already studied isolation property and acid properties. So here we have a normal sequence, T1, T2. First T1 is executed, then T2. T1 got a value, made it to 135. It was 30, then 30, the 35 plus 100 made it to 135, but after that it rolled back. So the value is 35 again. So this one actually got cancelled. Also this one got cancelled due to rollback, and the previous value is maintained. T2 got this 35 and subtracted 30 from it and made it as 5. Both are in serial, so there is no conflict. But here T1 read the value as 35, added 100 and made it to 135. After that T2 read this value. Now with T2 quantity on hand is 135. But once this value is read by T2, after that T1 roll back this value to its previous state, and meanwhile T2 was using this 135 and it subtracted 30 from 135, so T2 made it as 105. Now if we look into this scenario, by rule T1 made it as 135 but later it cancelled it, so the value should be 35, but during this process due to the concurrency T2 got this 135 and processed it, even though this was reverted, this was rolled back to its previous value. So here we got a wrong value from T2. If you calculate this again, you will get something else, because the value of quantity on hand according to T1 would be 35 and according to T2 it would be 105. Then inconsistent retrieval problem occurs when a transaction calculates some aggregate function over a set of data while transactions are updating the data. If you remember, we have studied the aggregate functions. These are average, sum, minimum, maximum, count, etc. So some data may be read after they are changed and some before they are changed, yielding inconsistent result. We have some data here and one transaction is going to change a value and another transaction got all these values and took, let's say, sum of these values, but after taking the sum one transaction made a change, so the sum, ultimate sum, would be different from the sum of these values. Here we have two transactions, transaction 1 T1 and T2. The T1 is using an aggregate function for taking sum of quantity on hand. So this T1 will get the sum of all the rows under quantity on hand column, all the values of QOH in the table, and transaction 2 is updating two rows in the table, and in these two rows the quantity on hand values are changed. In one row the value is added with 10 and in second row the value is added with subtracted with 10. So here if we look into this select statement, it is just like taking sum of all these, so it would give us, let's say, 92 for these values. And if we look into these two statements inside the T2, these would change these two values. In first statement 10 is added and in second statement 10 is abstracted from the value. Now if we look into the sequence in the program, so here transaction 1 read the quantity on hand and it got 8, this first value. Then again read from the quantity on hand, got 32 and took sum of these two due to the sum function, so it got 40. So 8 plus 32, 40. After that, T2 made some changes to a value in this table. It read this one value and made it as 25 by adding 10 due to this statement. T2 writes this 25, the new value. So this value is added in the list. So according to list, now this one is 25. And T1 read this one and this one till now. This one T1, this one is also read by T1. After that, T2 read 25 and then 23. So T2 read this one now after this change and also read this one. And due to sum, the sum of all these are calculated here. And due to the change, this one is 65 and before it was 88. After that, T2 took another value, that is 23. This one is already read by T1, but now T2 took it and made some change in it, made it to 13. And here after that 13 is written, means this one is now 13 even though it is read by T1. Then T2 committed, the changes are made. T1 now read the remaining two values, these are 8 and 6, and took sum of all these values. So ultimately it got 102. Now by rule it would be 92, but what happened here, T2 changed this value and T1 considered it. Here T2 changed this value but T1 did not consider it because before the change T1 already read it. So in this way the end result got corrupted. This is the example for inconsistent retrievals. So in today's lecture, first we studied about the transactions, then we checked that how these transactions work, then need of transactions, why do we need transactions. We have different reasons for using the transactions, how these transactions are evaluated. The main thing is that these are performed by DBMS internally. Then we took an example for transaction processing. In this example we used 5 sample QEs and checked the possible cases. Then asset properties were discussed. By asset property we mean the atomicity, consistency, isolation and durability. These properties are considered as the transaction properties and these are essential for transactions in DBMSs. We studied these properties, and then in SQL the transaction is standardized by ANSI and two statements, commit and rollback, are used. And after that we check the 4 cases, and then we studied about the transaction logs. In transaction logs we checked the main components of a transaction log. It is itself a database, and this database is stored by DBMS for recovery of records. Then we studied about the concurrency control. Multiple transactions may execute at the same time. So controlling such type of transactions come under the concurrency control. Here we have three issues with the concurrency control. The first one is lost update, the second is uncommitted data, and the third one is inconsistent retrieval. So we checked these three types with some examples. In examples, we took two transactions, and in first case, we showed that both are in serial, both transactions are in serial. In second case, we showed that both are executing in parallel and what type of issues can come with this parallel execution. We showed these things. Then uncommitted data problem is also discussed with an example. And the last thing is inconsistent retrieval problem, which is about the aggregate function. And here in this example, we took the sum function and we studied these things in today's lecture. I hope you will study these by yourselves. If you have any question, you can put your comments on QCMS. Thank you.